is defined by the instant at which the upper edge of the sun peaks over the eastern horizon in the morning. The term sunrise can also refer to the entire process of the sun crossing the horizon and its accompanying atmospheric effect. Similarly, a sunset is the daily disappearance of the sun below the western half of the horizon. The colors of sunrises and sunsets result from small molecules and particles in the atmosphere changing the direction of light rays due to a phenomenon called Rayleigh scattering. As light waves are scattered, the color of the sky changes. What color the sky becomes is determined by the wavelength of light and the size of the particle. Blue and violet lights are scattered by molecules more than the other colors in the spectrum because of their short wavelengths. Small particles such as oxygen and nitrogen play a large role in scattering. As the sun approaches the horizons, like it does during sunrises and sunsets, the light waves travel increasingly longer paths. As the light waves travel, the blue light is almost entirely scattered out, resulting in a warmer colored sky. Seasons can affect the appearance of sunrises and sunsets. Bright sunsets appear in the fall and winter, especially in the east, because the air along the path of the ray of sunlight tends to be drier and cleaner. It is difficult to calculate the visibility and exact time of sunsets due to unpredictable atmospheric conditions that change the amount of light refraction that occurs at the horizon. Even when there are clear skies, the times calculated for sunrise and sunset could be off by 1 to 3 minutes. The visibility of sunsets also depends on the mountains along the horizon and the position of the person in relation to the horizon, which cannot be factored into calculations. Aerosols, solid or liquid particles suspended in the air that originate from natural processes or human activity, affect the appearance of sunrises and sunsets. Natural aerosols can enter the air from forest fires, mineral dust, sea spray, and volcanic eruptions. Soot from vehicles and the burning of fossil fuels can also release aerosols into the atmosphere and affect sunsets. Craig Boren, professor of meteorology at the Pennsylvania State University, explains, "In an atmosphere with no junk at any time, you'll never get a sunset that would make someone with normal color vision say, 'Wow, that's red.'" He affirms, "It is certainly true that the pollution results in redder sunsets. This happens because small particles scatter short wavelengths such as blues and violets more than long wavelengths such as red. Many man-made aerosols are small enough to meet this criteria, which contributes to the deep crimson sunsets of polluted cities across the globe." At a certain point, however, pollution can become so bad that the sun cannot be seen clearly. Clouds play an important role in sunrises and sunsets because they are excellent at reflecting light and taking on different colors. This is why during a sunset there are beautifully colored clouds along the eastern horizon as they are reflecting the vibrant hues of the western setting sun. High clouds take on the colors of the sunsets more than low cirrus or altocumulus clouds because they are able to intercept sunlight before it loses color passing through the atmosphere.
Cloud droplets are large enough to scatter all visible wavelengths more or less equally. This is called mi-scattering. This means that almost all of the light which enters clouds will be scattered. Because all wavelengths are scattered equally, clouds appear to be white.
Mi-scattering is responsible for the light scattered by clouds during sunsets and sunrises. Without mi-scattering at sunset and sunrise, the sky along the horizon would have only a dull reddish appearance, while the rest of the sky would remain mostly blue and sometimes green.
So when the sun is behind a curtain of rain, the white light of the sun hits the raindrops. The raindrops act like tiny little prisms which shoot off the rays of the sun into different angles, forming a rainbow.
In order to predict the time of a sunrise or sunset, the refractive index must be calculated. Many assumptions are made during the multi-step calculation, which causes slight variations between the calculated time and the actual time of the event. The first step involves creating a model of the atmosphere, specifying surface pressure and average temperature as a function of height. Next, density is modeled using gas laws and known information about the atmosphere's composition. Refractivity, the turning or bending of light waves as they pass through objects of varying optical density, can now be plugged into a differential equation. Refractivity changes with changing wavelengths, and when it disperses, green flashes occur. Green flashes are optical phenomena that occur shortly after sunset or before sunrise when a green spot above the sun is visible for a few seconds. A green flash is more likely to be seen in stable, clear air when more of the light from the setting sun reaches the observer without being scattered.
Each year, the environment covers more than 40% of the Earth. Every animal on Earth lays eggs. This is a birch tree. Today, it will begin its 10,000-mile journey. The Earth neither hates nor loves, but sits waiting patiently for people to do famous stuff.